Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Before we proceed, I'd like to kindly request our members to subscribe to our channel, engage us in the comment section, and also check the various links that we normally put in terms of our playlist. They contain various ranges of videos, which of course are going to be discussions on these specific or related topics. So today we're going to look at the concept of differentiation of a trigonometric function. And basically, we're going to do a short discussion on the concept of the cosec of a function. Basically, the cosec of a function is a function of the inverses of one of the trigonometric ratios. And we have said that for trigonometric ratios, which are basically three for the sine, the tangent, and the cosine of a function, they're going to have their various inverses in terms of the sec, cosec, and cot, as I had mentioned in our earlier videos. So in this case, the cosec forms one of the inverses of this trigonometric function, and basically this implies the inverse of the sine of a function given as such. So therefore, if we are requested to find the derivative of cosec as one of the inverse of the trigonometric function, this implies that this basically represents the cosec or the inverse of the sine of a function given as such. So therefore, this particular representation calls us to employ the concept of one of the rules that we have discussed. And this is one of the differentiation rules that we had mentioned on the concept of the reciprocal rule. So from the reciprocal rule, we said that if we have a function gx, or if we have a function, g is differentiable at x, and gx is not equivalent to 0, and then 1 over g is differentiable at x, and the inverse, which is basically the reciprocal of 1 over g of x, is given in terms of the product of negative 1 over gx, the square of gx, g prime over x given as such. So this basically is a theorem that gives us the condition under which this specific concept of the reciprocal rule is applicable, whereby if we have a function g that is differentiable at x and gx is not equivalent to 0, then 1 over gx is differentiable at x, and 1 over g prime over x is equivalent to negative 1 over g squared, the square of 1 over gx, and then g prime over x given as such. So we're going to employ this specific condition that we've been given for this equation of the reciprocal rule in order to solve this one of the inverses we have for this basic trigonometric function over sine. So we're going to see that therefore the d over dx over the cosec x implies 1 over the sine over d over dx, 1 over the sine over x. So basically we're going to use the right side of this specific representation, which is negative 1 over, so the square of gx in this specific case represents the sine over x. So therefore the square of the sine over x is given as the square of the sine of x given as such, and the derivative of the sine over x basically implies that, or rather the derivative of the sine over x implies basically that this is the cosine over x. So therefore we're going to have the cosine over x given as such, and this is going to give us basically a product of negative the cosine over x over the square of the sine over x given as such. And this basically, if we try to split it aside, given it from the first description, the cosine over x over the sine over x basically implies what we refer to as the cot of x. They said that for us to find the ratio between the sine, we have this small space. I said that we have the tan x given as the sine x all over the cosine over x. Now, if we have the inverse of this particular if we have the inverse over this particular representation, then that is going to give us what we refer to as the cosec of a function, and this is going to be given in terms of negative the cosec. So this is going to be given as negative the cosec over x, and then cot x given in that specific order. So we're going to split the sign. We're going to split the sign so that we are going to have from this specific representation, we're going to have negative the cosine over x 1 over the sine over x, and then dot 1 over the sine over the sine over x given in this specific order. So the product between the negative cosine over x over sine over x dot 1 over sine over x, which is the product. So this specific ratio is going to represent the cosec, which is appearing in our first part of this specific product. So since this one was a negative, it's negative the cosec over x. And then the cot over x implies this specific ratio we're going to have for the cosine over the sine, which is an inverse over this specific function as or rather the inverted form of this specific function which I mentioned. So basically, the derivative of the cosec over x represents the negative cot cosec over x, cot x given in that specific order. So basically, this is how we're going to find the derivative of this specific function by employing this part of the discussion we have had on derivatives of the reciprocal rule in this specific procedure as I've already done. So that is it for now, guys. Kindly check our description boxes for various links of other similar videos which are going to assist us comprehend this particular topic on the concept of differentiation. So that is it for now, guys. Bye, God bless you. Catch us in our next video.